Section 11.2 Transparency of Materials. So we refer to a material as being transparent if a light wave can pass through it. If light can pass through the material without interacting with the material, then that material is transparent. Now we think of transparent as being things like windows, but that doesn't always have to be the case. Transparent can refer to any object allowing any type of electromagnetic wave to pass through it. Materials that do not allow light waves to pass, we call those opaque. And so, for example, windows are transparent to visible light. You can see through them, but they're opaque to infrared light or infrared radiation. X-rays can penetrate your skin, but visible light can't. And light will appear darker on a wet surface than a dry surface, because on a dry surface, most of the light is reflected, and on a wet surface, some of the light is absorbed before it is reflected. So how opaque or transparent something is depends on the frequency of the electromagnetic wave and the material in question. So whenever light is incident on a surface, whenever light hits a surface, the light causes electrons in the substance to vibrate. Light will essentially hit an electron, and that electron will absorb it. And the electron will either absorb it as heat, and no light will pass through it, or the electron will absorb it and then re-emit it as a light particle, what we call a photon. We refer to light as a particle, as a photon, and as a wave. And so when we refer to photons, we're referring to particles of light, but those particles of light are essentially little wave packets of light, little envelopes of waves, little envelopes of electric and magnetic fields. Now, though Einstein is best known for his E=mc², that's not why he received a Nobel Prize. Einstein received his Nobel Prize for his paper on the photoelectric effect, which showed that light incident on a piece of metal could interact with the atoms in the metal, with the electrons in the metal, and knock them off of the metal. Thus, he was able to show that light can behave both as a wave and as a particle. But in general, the wave nature of light is what we most observe. And because light is a wave, it will travel at different speeds when it travels through different materials. In a vacuum, which means in space when there's no air or anything around, light travels at approximately 300 million meters per second. In the atmosphere or in the air, the speed is only slightly less, 99% of that. It slows down a little bit. In water, light slows down significantly. It can only travel at about 75% the speed that it can travel in a vacuum. In glass, that speed drops to 2/3. And in diamond, light only travels at 41% its speed of light, less than 150 million meters per second.